next video. So today we will be learning about casting. So suppose you have a float value and an unsigned int value. Now you want to do a division for those values. So you can't do direct division as Rust won't do implicit casting for you. You have to specify explicit casting. So for this we are converting the unsigned int as f32, then only you can do division. Next concept is shadowing. So you can define the same variable multiple times and give it completely different data types I'm not sure where exactly would this be useful, but I might try to avoid this kind of a thing because yeah, this might cause a lot of confusion. Next is scoping. So you can see that there are these curly braces, so that defines a scope. So you can do anything within a scope, and variables defined within that scope can't be used outside the scope, so just like a function. Next are enums. So I have defined a normal enum over here, and you can see that I have defined derived debug at the top of that enum. That is used whenever you want to you use that enum alongside the println macro. Otherwise you won't be directly able to print that enum. Next would be, so here you can see that I have in next example of enum, you can see I have assigned 0 to a. So b and c are 1 and 2 because values of an enum are automatically incremented. But in the next example I have assigned 4 to b, but a is still 0 because enum starts at 0, but value of c would be 5 because they are auto incremented. In the next case, a is 4, b is 3, but this would give you a compile time error because enums are automatically incremented, so c would be again 4, and a is also 4, which will kind of cause conflict. So for this you have to define explicitly some value for an enum. Next is so enum does not have to be of same data type, they can be of any data type. Next is the impl keyword. The impl keyword is used along with struct to implement methods for it. If a method takes a struct as an input, you can refactor that method inside the impl block. So I have defined a struct over here, and it takes a property called degrees underscore f, which has an f64, and now I am defining an impl temperature for it. Okay, and it takes two methods. So the temperature impl is name is same as that of the struct name, and now I am defining two methods, freezing and show underscore temp. You can see that the freezing returns a capital self, and in show temp we are borrowing and it has a small self. So the difference is the capital self refers to the actual struct. Whenever like you want to create an object of the struct, you would use the capital self, and the small self refers to like whenever you want to pass the object of the struct, not actual creating of the object, like whenever you want to pass the value to show underscore temp. So that is what is done. So for now I have created a temperature struct manually, and I can automatically call show underscore temp because it is part of the impl for that particular struct. You can also create a struct directly using the freezing method of the impl of temperature, because that takes a capital self, and that indirectly tells you that you can directly create an object for the struct, and you can again call show temp for the same. Yeah, that's it for today's video. Thank you for watching. See you in the next one.